Hi all, good morning. Sorry for not being in Zaragoza. It's really pity for me and for the two guys I'm going to present their work. So the first one is Mohammad Amin Hosseinifard. He developed his research work concerning vertical integration in end-to-end product process value chain in Industry 4.0 environment. This is his thesis, and I'm going to present some parts that I consider of particular interest for all of us. So after the acknowledgement, you can see here Digiman 4.0 and all of you for contributing to his research work. We can see that his activity is meant to explore the field layer, the control layer, and the supervisory layer. So very low layer of the pyramid of automation. The activity Amin has performed is oriented to develop systems and algorithms in order to improve the communication between the low level and the higher levels. Here you can see different publication he made during these 3 years research work. So a good set of publication. I would like to show you the activities he did in this activity. So we said that he focused on the field level, so mainly sensor and actuators, but on their ability to communicate with PLC, the embedded board, and on the other layer that is integrating all this data and sending to the SCADA. So having some screens, HMI, interactive system, but also he developed something concerning virtual reality for SCADA. Here are some problems, but let's focus on the two research questions I consider of more interest. The first one is how can parameters on the factory shop floor be digitalized and transferred wirelessly using various energy harvesting and communication technologies? So two different pillars: getting data out of all machineries, but also from devices that are not connected. The idea is that you can gather this data from analogical indicators, levers, and so on, that are fundamental in order to understand how these systems are working or what is their status. But the other problem is, okay, I can get this data, but how communicate, how to make them able to communicate. There are different systems that he analyzes in order to see if it is possible to harvest the energy necessary to feed the data to the upper layers. Let's see what he did. He passed it through IoT edge devices. That is less relevant for his publication, but I'll focus later on. And the third research question is interesting as well, since it goes upper. So on the integration of virtual reality with real automation world. The question is, how does the integration of virtual reality technology with traditional SCADA system enhance real-time monitoring and data interaction? This activity has been performed in the maritime industry, in particular in yacht, small and medium, and it has been also applied in the automotive field in both Pierburg, the company where he spent his internship period, and also in Vitesco, one of other partner of DIGIMAN project. So the activity concerning energy harvesting has been published by IEEE journal, and in particular you can see here the double word, the word of harvesting by using thermal harvesting, solar harvesting, radio frequency harvesting, and piezo harvesting for getting the vibration and transform them into energy. But this energy is fundamental to capture the data from the field, from the environment, and then to be transferred thanks to different technology from, for example, from Bluetooth low energy to LoRaWAN, RFID, and so on. This status of the art was pretty important in order to understand what can be used where. The result, okay, it is quite extensive, is that we can have different approaches, but the energy could be enough to feed the data that are gathered at very low level by using vibration lights at the remote edge. But it is very difficult on the node. So for the edge, it is feasible, the energy we harvest is enough to make the system able to collect the data and to send the data. This work was fundamental in order to understand if it was possible to digitalize also analogical devices. Here, the concept of RFID capturing system in different part of all the assembly line on analogical devices, and how to make it possible to transfer the data. Well, it is important to say that by using standard RFID technology and using a parasitic element is this stuff like here, this metal stuff, it is possible to gather the energy coming from an RFID antenna to store in some way in the metal material and feed to the small RFID system here, to the small antenna here. So imagine to capture the data concerning the status of an analogical indicator, a pressure system, a manometer that measures the pressure in a fire extinguisher that is disconnected. But you have an RFID system there that is able to capture these the energy, the electromagnetic energy coming from the antenna, send to the RFID reader, have enough energy to sense the status of the analogical device, and then using the energy to feed back the data concerning the pressure or the status of the fire extinguisher directly to the antenna. So the development of this system was very interesting, and he made a lot of work concerning simulation, integration with real devices. He's also developed his own system to make the system even more efficiently with respect to the commercial ones. And here, different curves concerning different RFID with different dimension, antennas, and so on, and parasitic elements. Here, the simulation performed in order to understand how this system behave in a 3D environment. And then here you can see the results. So we can detect where the indicators is located and understand if it is in the green zone or in the red zone. And this data can be fed once in a day when the antenna passes through the shop floor in order to gather this data. This data do not evolve very fast. So harvesting or capturing once per day is more than enough, or could be enough. But this work was also used to understand if it is possible to sense a system like that at quite far distance. You know that a RFID reader or tags can be read very close. Okay, by using a combination of what you saw before, it is possible to read from very far, and very far means 10 meters. What was the system? The system was made by using parasitic frames around different antennas, RFID antenna, We made the setup and we analyze how this system behaves in real open space. And the result is quite good, as you can see, by using these parasitic frames. It is possible to improve anyway the distance you can read the data. In one case, you can over-exceed the 10 meters. That is very far. So you can imagine that someone, for example, someone in the logistics or in the cleaning, pass through all the area of the company and with an antenna, a RFID antenna that send the electric energy, the electromagnetic energy to the parasitic element. The parasitic element transfers to the RFID reader that get the data out of a sensor, for example, the temperature. Then this data is collected and transferred back to the antenna. And that you can read from very far. So people can move and gather the data that are almost hidden in a standard component. This data can be integrated at IoT level, and there is a part that I will present you later on because it is more on Marco's work. And here the SCADA. So this one is a SCADA control room, and the SCADA control room is not an easy place where to understand how the machine work. Imagine in a yacht, so maritime industry, the owner of a yacht that would like to know how his boat is running. He has not the skill of a SCADA operator, but it is important for him to be able to detect if failure, and maybe thanks to remote assistance to decide how to adjust the parameters of his boat. So the activity was concerning the development of a virtual reality system by Oculus, where the owner of the boat can move in the boat, see the different part. Also, the part could be even hidden, but it could have access to the different parameters, and having also system that highlights, alerts, what is happening in his boat. The result is actually the following. Thanks to the virtual reality, it's possible to transform the standard data presentation into something that is more likely to be accepted by a not expert. For sure, the virtual SCADA console will remain, but it will, so the standard approach to SCADA will remain. But in this case, a SCADA operator could have access to a system before the system exists, so learn in advance. For the user, the final user, the owner of the boat, the SCADA room is meaningless. So it is important to have access to the reality, in this case virtual, of his boat in order to understand how his system is working. And here, what Amin did. So he prepared the environment in the 3D. He collected all the data concerning the machine and virtualized the standard SCADA into a real 3D environment. For who? For the operator that could start interacting and learning before the actual boat or the actual system is built. For the operator, for the owner, the environment is quite different. He doesn't see the schemes, the drawing, but he sees exactly the real engine in this case, where he could detect the oil temperature, the water, the charge, and so on. So it is really lowering the barrier for someone that is not expert and would like to understand how his or her system are working. The same could be applied in SCADA for a standard manufacturing environment, and Amin did this activity also for Peerbook, the company where he performed this internship, and also in Vitesco, one of our partner of DIGIMAN. So this is almost the work. Amin ended his thesis, and now he's going to send the second version of the thesis to the reviewers after their comment, and hopefully he will discuss the thesis in the next month. Thank you very much for your attention, and I hope to see you soon.